Hello, everyone, and welcome to the Toronto General and Western Hospital Foundation virtual live stream, expanding the boundaries of epilepsy research. I'm Christian Cote, host of the UHN podcast Behind the Breakthrough. We hope you're staying safe and well and taking care of each other during this challenging time of the COVID-19 pandemic. We're glad you could join us and grateful to you, our family of supporters. Your generosity is what fuels the groundbreaking research that translates into world-class care at UHN. So a big thank you on behalf of the foundation and all of UHN. Today's broadcast on the eve of Purple Day is part of UHN and the foundation's commemoration of this important day, held every March 26th. Purple Day is an international grassroots effort to increase awareness about epilepsy and dispel common myths around this neurological disorder. So tomorrow, we encourage you to wear purple to honor the people and the families who are living with epilepsy and to promote awareness. Today, we're joined by two renowned and world-class clinician scientists to talk about the Krembil Research Institute. Dr. Danielle Andrade is a neurologist and medical director of UHN's epilepsy program, the largest and most comprehensive adult epilepsy program in Canada, and a clinician investigator at the Krembil Research Institute. Welcome, Dr. Andrade.
Thank you.
Dr. Esther Bui is also joining us. She's a neurologist and leads the biggest epilepsy pregnancy clinic in Canada at UHN's Toronto Western Hospital. As well, Dr. Bui is a pioneering researcher in the care of women with epilepsy. Welcome, Dr. Bui.
Thanks for having me.
In addition, a little later in the broadcast, we have a special guest joining us. And a note to all of you out there in the audience, we want you to be a part of today's conversation. So if a question comes to mind while we listen to Dr. Andrade and Dr. Bui, we'd love to hear from you. Just click on the Q&A button at the bottom of the screen and write us. A little later in the broadcast, we'll open the floor to your questions. And keep in mind, for privacy reasons, we ask you not to include any personal medical information in your question. All right, let's get started. And I want to turn to Dr. Andrade first. It would be helpful, I think, Dr. Andrade, if you could give us just a brief overview, understanding of what is epilepsy.
Well, epilepsy is an abnormal electrical discharge that happens in the brain. And patients that have epilepsy, they have these seizures that are the result of this abnormal electrical discharge. And the seizures might have different manifestations depending on what part of the brain is affected. So if it is a small part, or they may just have some kind of subtle movement. Sometimes, depending on what part, they can have just a blank stare, but also they can have the convulsions that we are more familiar with. In addition, some of the problems with epilepsy is, number one, the unpredictability. So you never know when you're going to have another seizure. The fact that epilepsy often has comorbidities, so other problems that come with epilepsy. In some cases, is depression and anxiety. For other patients, can be learning difficulties or even autism spectrum disorder. And finally, the medications that we use to treat epilepsy, many or most of them have some side effects. So even if we can get the seizures controlled, most patients will have some form of side effects.
And Dr. Bui, what's the scope and scale of this disease across Canada?
That's a great question, Christian. As far as we know, approximately 300,000 Canadians have epilepsy, but I'm sure that's the tip of the iceberg. Oftentimes, much more can have experiences of seizures in their lifetime. Up to 10 to 25% of specific groups of people have an experience of a single lifetime seizure. But about 300,000 Canadians are experiencing epilepsy as we know it.
And Dr. Andrade, give us a sense of what's on offer when it comes to a cure or treatment for people with epilepsy.
That's the tricky part. We don't have a cure today. So some forms of epilepsy, the patient might grow out of it as the patient gets older. So some that affect children, these children may grow out of it. But for the majority of the people with epilepsy, there is no cure. So very often we can manage the seizures, we can control the seizures with medication, but as I said before, Many of these medications have side effects. 30% of patients will still have seizures despite taking medication. And this is a very challenging population and that's most of our focus here.
And Dr. Bui, I understand a number of patients become drug resistant, so their medications no longer control their seizures. What's their quality of life once that happens?
Another great question. And I think it's really the invisible struggle that many patients with epilepsy have. There's more to epilepsy than just medications alone. So quality of life issues, deciding when and if ever to have children is a really important question for many people, men and women alike. But getting gainful employment, being able to make it to their doctor's appointments, the financial means to care for themselves and their families, those are really important aspects of epilepsy that is beyond just a medication.
So this is where, the critical nature of the work at the Krembil Research Institute comes in, because that's where really the hope lies, right, is research. And Dr. Andrade, why don't we start with you? I understand you're one of this country's pioneers when it comes to investigating the genetic underpinnings of epilepsy. Could you walk us through the principle behind this type of research that you're doing?
Sure. So right now, the medication that we use for seizures is usually like a standard medication. It's just like you just treat the symptoms. We don't really know what is causing the seizures. With the technology and the way it has evolved over the years, we are now able to identify the actual genes that cause epilepsy. And this is part of our work here. So we take patients' DNA from the blood. We do just like a regular blood work, and we extract the patient's DNA. And then we have several ways of sequencing their DNA. And we do very sophisticated sequencing where we look at the entire genome, both the part that codes genes and all the rest, which is parts of it is just to control the genes expression, and parts of it are things that we are still learning what they do. But it's a fundamental process. If you don't know what's wrong, you can't really treat the patients. So learning why they have epilepsy, which gene is abnormal, lets us plan what is the best treatment.
So talk to us about what you've discovered in terms of being able to locate these genes. How do you do that? And what's the purpose then of the research? What can you do with that knowledge?
Okay, so there are certain types of epilepsies, some of the most common forms of epilepsies, where the gene signal is very low. So you actually need thousands of patients to find this genetic signal. And we are part of a large collaboration where we are aiming at sequencing the DNA of 25,000 patients. We already sequenced 19,000 patients. And with this large number of patients, we were able to detect this very weak signal telling us what are the genetic markers that lead to epilepsy. Then you have the other extreme of patients with epilepsy that have a very severe form and usually associated with comorbidities like intellectual disability and autism, where you actually don't need this very large number of people because the signal that comes from the abnormal gene is very strong. So you can detect that with a small number of patients. So we are working on both ends of the spectrum, finding genes in rare forms of epilepsy and finding genes in common forms of epilepsy. With this knowledge, the plan is to develop better drugs, better treatments, and even gene therapy, which I think we're going to talk a bit more later.
Yeah, well, the vision, I'm guessing then, of course, always with this type of work is to translate it into where it impacts patients. Talk to us about then where your research or where you see your research going to be able to move towards that translational part to impact patients.
So once you know what is the gene that is abnormal, you can start to understand what are the possible pathways that lead to this abnormal electrical activity in the brain. And then you can think of ways of treating the root cause of the problem rather than just taking care of seizures, which is kind of not ideal solution. So you can actually make sure you have the correct balance in the brain so you don't have those abnormal discharges anymore. And that is something that might be done through medications, through what we call orphan drugs, so drugs that are developed for very rare diseases. And like I said before, gene therapy. If you asked me a few years ago, I would say, well, gene therapy is something far in the future, and we don't know exactly how or what kind of gene therapy method is going to work. What I can tell you now is that we already have different ways of delivering or correcting the genetic abnormality, and some of these are already in clinical trials. So once you have an abnormal gene and you have you know how you can correct, you start first with testing that in cells, and then you move to animal models, and then you move to more sophisticated animal models, which are the non-human primates. And then once you have all that information and the knowledge that it is safe, then you move on to gene therapy in humans. And this is something that is already happening for some forms of rare epilepsy.
Wow. So just so I understand, when you talk about you're able to identify the gene that has mutated that causes the epilepsy, you're then moving towards, in terms of the research, gene therapy. Is that therapy purely a therapeutic drug, or are there other ways to create gene therapy?
There are many different ways, but think that every single cell of our body has all of our genes, right? The genetic code is on every single cell. And the cells that you want to correct are the cells in the brain. And the brain is kind of protected. So some medications might not get to the brain if you just swallow them. So we might need an injection to deliver this form of gene therapy inside the brain. And that is something that is already being done for other forms of brain disease, not specifically for epilepsy. Epilepsy, now there is one trial going on, but it's not something that is, it is safe. It is, of course, more labor than just taking one pill or several pills every day, but it's the ideal treatment because it's going to correct the problem without causing side effects, which is what the medications do.
And talk to us about the importance of your work of collaboration. You mentioned earlier collaboration with other groups. How does that play into being able to really drive this research towards impacting patients?
Okay, so there's several aspects of collaboration. So we collaborate with other groups to make sure that the mutations we find in our patients here in Toronto, here in Ontario, are real, are valid, and are seen in other populations. We also collaborate in the sense of understanding what is the natural course of the disease, how the disease evolves naturally. Because if you want to give a treatment, you want to make sure that it's not just the seizures, especially if you're talking about gene therapy for these rare forms of epilepsy. It's not just the seizures that have to go away. All the comorbidities have to go away. And we need to understand what are the comorbidities a little better. And if we're talking about rare diseases, we really need to work with other researchers so we can compare what our patients have with what their patients have. And so we can understand how the disease evolves over the years. And if changing Doing the gene therapy now will prevent all the other comorbidities in addition to protecting from seizures.
And I understand, Dr. Andrade, part of your research involves a push to build an Ontario-wide registry of patients in this province with a single gene causing epilepsy. What's behind that initiative?
So this is the reason why we are doing this is because right now, these patients with single gene epilepsy, they are a little bit scattered all over the place. And Canada is a large country, but with a relatively small population when you talk about gene therapy. So usually the companies that are doing gene therapy, they want to go to places where they have a lot of patients. And if we don't get together, Canada will not attract clinical trials. So think of someone who has a child with a very severe epilepsy, and this patient is growing up having seizures, and the memory is getting affected, the intellectual abilities are getting affected, and you see a similar child in the US or in Europe who is allowed to be part of a clinical trial for gene therapy because they are in the right place. And we can't offer that in Canada because the companies say, well, there's only a few patients here and there. So if we do a registry, we're going to be able to show that we actually have a lot of patients, enough to go through all the regulatory paperwork that is necessary to go through with Health Canada. And we have one big advantage in Ontario, actually, which is the Clinical Trials Ontario, which is an organization that helps coordinate clinical trials for different conditions. So if we get our patients organized under this registry and we connect with Clinical Trials Ontario, which we are doing right now, it's going to be much easier to bring this kind of clinical trials to our population in Ontario and then eventually expand to the whole country.
That's fantastic. Very forward thinking. Many scientists I interview on the UHM podcast Behind the Breakthrough stress the importance of being open to wherever the research takes you. And I understand you made a recent discovery thanks to serendipity of being open to what you were being shown. Can you talk to us about that?
Yeah. So this is a patient that she came to the hospital and she had several seizures and she developed psychosis after the seizures. And she received the label of post-ictal psychosis, which is kind of a rare thing, but it happens. We know that patients sometimes, if they have lots of seizures, they develop this psychosis. Turns out that this patient had more than what we would expect for a post-ictal psychosis. She continued to have psychotic problems. And we identified the genetic abnormality that she had, which is called PCDH19. That's the name of the gene. And then I started asking around my colleagues internationally if they had any patients that also had something similar. And turns out that they started saying, well, I've seen one. And then we worked together in an international research, and we collected several patients with this disease. It's a disease that affects women much more than men. And it turns out that it's not just the post-ictal hallucinations that they have. It's not just related to seizures. They actually have a much higher chance of developing schizophrenia. So it turns out that we figure out that this gene is the second most common cause of schizophrenia in the population. So because we were paying attention to our patient and things like, of course, the seizures and the medication, but all the other things that our patients have, we were able to observe this, and we knew the genetic abnormality, and we looked for other patients with the same genetic abnormality around the world, and we were able to identify this common trace that all of them had.
So you were essentially helping the schizophrenia field advance in terms of research by identifying the gene that contributes to schizophrenia.
Yes, in a way, yes. But definitely we are helping our epilepsy patients who were receiving the label of post-ictal hallucinations, when in fact they have schizophrenia and they need better treatment and better psychiatric doctors to follow them. Yeah.
That's terrific. I love stories like that. All right, let's bring in Dr. Bui. Your research focuses on epilepsy in women specifically. So what's the origin story here? What led you to choose this area of research?
So I'm going to have to preface this by apologizing for any puns that come out, but this is an area of research that's really intent on creating a epilepsy program for women specific to women's issues. And I have to give you the personal story, which was I was very much pregnant with our first daughter when I finished my fellowship training in epilepsy, and realized that there was a really unmet need to match what some of the challenges women go through during pregnancy and balancing this with their epilepsy. And so that led me on a 2-year journey to really explore kind of worldwide, what are some of the best practices? How can we do better for our women in Canada? And that ultimately led to the publication of the book that I'm very privileged to have co-authored with Dr. Autumn Klein. And from there, it really has opened many avenues, much like what Danielle has described, is keeping an eye intently open for the needs of our community and the needs of our patients, and how can we work together to bridge those gaps that are very glaring for many patients. And the big gap that I saw was that there were still unmet needs for our women who are becoming pregnant. It's a time that's filled with anxiety and fear, rather than empowerment and autonomy, which is what we all as physicians strive to facilitate. And so after the book was published, I reached out and began looking to see where we could make connections. And as this is truly a labor of love, many others were doing the same thing, but just really not in a coordinated fashion. So since then, we've created and designed really Canada's largest pregnancy and epilepsy clinic. There's myself leading this, but very important players such as our nurse practitioners, our social worker, there's dietitians involved, as well as our obstetrician and anesthesiology team. And together we're able to provide more comprehensive care. And this has led to research. And so one of the challenges that Canada has is there's really no data on what Canadian women who experience epilepsy in pregnancy experience and what are their outcomes. And worldwide, we're recognizing very quickly that women are severely impacted by seizures, especially when medication levels drop. And equally important to women and their family is that their medications can impact the health of their babies. And we know that valproic acid is probably one of the biggest offender, with up to 10 to 20% of babies having a major congenital malformation. And that yet there's very little Canadian data to help guide us on how to care for our Canadian women. So this is a really exciting time. We are launching a Canada-wide survey to understand how doctors are treating women with epilepsy across Canada. And this is about to be launched tomorrow through the Canadian League with the Subcommittee for Women's Issues in Epilepsy. And we're looking closer to home. We've just had approval just yesterday, actually, to launch our research project to look at the outcomes of women at both UHN and Mount Sinai on, are we meeting their needs? Are their seizures remaining well controlled? And how are their babies once they're delivered? So it's an exciting time from birth to now it's infancy.
That's amazing. In terms of, you talk about gaps, which really is what drives a lot of research, being open to understanding what are those gaps in care. What other areas is your research going in when it comes to specifically women who have epilepsy and pregnancy?
It's a great question. One of the challenges we don't understand is with the explosion of new medications that have come on the market, how is that impacting the safety of their developing baby? And how much is it going through their breast milk? So we've just partnered with Sick Kids with a Canada-wide study looking at breast milk transmission for some of our anti-seizure medications. And we're pushing forward to study the transmission of the newer medications to breast milk. So there's a lot on the horizon. We still have to understand how can we better support women in choosing the right time to have children. And with the development of fertility methods, more and more women are realizing that epilepsy is not a barrier to having a family, and that there is support out there. There's fertility counseling as well as fertility medicine for some women who have trouble conceiving. And so all of that puts into balance a new set of things to juggle that women have to face and decide on what's best for them and their families.
And Dr. Bui, you have another research initiative that I read about called the Lullaby Project. Talk to us about the origins of that research initiative.
So this is a project that's really, really dear to my heart, having gone through 2 pregnancies and now with a little guy at home who still loves his lullaby. And a shout out to Vanessa Smith, who we've just partnered with. Vanessa is the head of education at Rory Thompson Hall. And when I heard what Rory Thompson was doing, I realized that this was necessary for our women with epilepsy, a tool that transcended medicine, that transcended the medical prototypes of how we can help women, and see how music can actually empower women. And so the Lullaby Project is a project that links women with singer-songwriters to help them design a bespoke lullaby for their child. And through that process of reflecting on their emotions, their challenges, and their anxieties, and designing not just a tune and a melody, but lyrics, and giving this as a gift to their child and their children's children, we'd like to explore how that can impact both empowerment, resilience, and quality of life. And so this is the beginning of a hopefully beautiful partnership with Rory Thompson. I'd like to share with you, actually, if we have time,
Yes.
one example of a lullaby that really, if they say a picture's worth 1,000 words, a song is worth 1,000,000. So I hope this song can demonstrate the power of what a lullaby can do.
My little lily, your first breath took mine away. God showed me a sign. Those big, beautiful brown eyes, just staring up at mine. I really knew my purpose had become you. Through the good and through the bad, through every tear I cried, in every life I made, you were there by my side. There's nothing in this world I wouldn't do to protect you. I love you. You'll always be my lily, no matter how big you grow. You'll always be my little girl. You'll never know how far you've helped me go. You're safe with me, I love you, hush, time for sleep.
I know the first time I heard this lullaby, I cried. And those words really speak really loudly to represent a mother's love, but also the struggle that goes through in pregnancy. And I can't imagine a greater struggle with the balance of that in epilepsy. So I'm hoping that with the collaboration of Roy Thompson and Vanessa, that we can push forward, again, no pun intended, to make this project something that women with epilepsy can access.
You've recorded, I saw, like dozens of tunes. Why don't you mention where we can listen to more of them?
That's it's available actually on Roy Thompson's website. And these are songs that have really demonstrated the work that Vanessa and her group have done for Jessie's House, which is a program for young teen moms who have struggled during their pregnancy for other reasons. This is the first of its kind, I think, in the world, that has looked at a chronic medical disease model for music. And just of interest, music has been associated with healing powers for epilepsy. Our group with Dr. Valiente's lead has demonstrated that Mozart can actually decrease seizures. And so there's no doubt in my mind that there's a power to music. How that can apply to epilepsy and women going through pregnancy is what we'd like to explore next.
Fantastic. You hinted at this earlier. You mentioned earlier the challenges or difficulties in terms of women with epilepsy and pregnancy. And I understand actually women with epilepsy are often discouraged from getting pregnant whatsoever. So talk to us about what it's like for you to be helping young women, navigate this journey of childbirth while managing their epilepsy.
Gosh, it's the best part of my job. And I say this almost every day, that the highlight of the 9-month journey with women and their families is to see this beautiful newborn child that has been brought into this world by oftentimes two really loving parents that want only the best for this child. And so it is a labor of love for this journey.
Pun.
Another pun. And I have to say, I questioned my observations in the very early part of the development of this clinic, but it's almost a 99.9% of the time that I meet a woman, and in the very first few clinic visits, it's oftentimes filled with anxiety and fear and uncertainty, and sometimes mistrust, because women come to a place at the beginning of their pregnancy with a lot of questions. And throughout the 9 months, it's almost inevitable that there is this transformation, and maybe thanks to baby as baby is developing, but also the empowerment that women express. By the time I see women in their second and third pregnancy, it's a different ballgame. These are confident women who know what they want, and conversations that are at the next level. So that's the best part of my job, is that the transformation has happened within our generation, but almost every day in my clinic, this transformation is happening very slowly, but perceptibly.
And your research focus in terms of women and epilepsy, it's somewhat in its infancy. Sorry, my own pun. Talk to us about the team and the vision you have for where this can go in terms of your research, Dr. Bui.
Well, I believe that Krembil really is placed to be the leader in Canada for women's health issues. We are, no woman ever wants to be associated with the word largest, but we are really not just by sheer size, but by sheer commitment and talent. There is an incredible group of people here in Toronto, and I've reached out to all of my colleagues in both Canada and also North America, and Toronto is at the table for leading the way, not just for understanding what we need to do for Canadian women, but also for women across the world. And so I think we're in a very exciting position. We're in the last stretches, no pun intended again, for pregnancy, in putting together an established and well-oiled machine to go to the next level, which is to be on that international platform. So I'm really excited, and it really is with Dr. Andrade's support as the director of the epilepsy program that this is even possible.
That's great. Be proud of your puns. They work for Ron McLean at Hockey Night in Canada, Dr. Bui. Okay, a quick reminder to our audience. We'll be getting to your questions shortly. If you have a question for Dr. Andrade or Dr. Bui, please write in. Just click on the Q&A button at the bottom of your screen. And please keep in mind no personal information, health information when you write into us. Okay, back to Dr. Andrade. Let's broaden the conversation a bit to some of the other research initiatives ongoing at the Krembil Research Institute. Talk to us about Dr. James Eubanks, who heads a team investigating Rett syndrome. Talk to us about his research focus when it comes to Rett syndrome, Dr. Andrade.
So Dr. Eubanks is an internationally renowned scientist in the area of Rett syndrome and some other epilepsies that are similar, or at least looking for a bit far, they seem to be similar to Rett syndrome. more recently, he has been working with an animal model, with a mouse model of form of, it used to be called atypical Rett syndrome. It's caused by a different gene called CDKL5, and we're going to hear about this gene soon. And he is actually, he has developed a mouse model that has a mutation that is seen in patients that have CDKL5. So now with this animal, he has the opportunity of, number one, understanding why these patients will have their seizures and their other comorbidities that they have. And also he has the opportunity of testing different treatments, again, from medications to gene therapy.
And bring us up to speed, if you don't mind, also, Dr. Andrade, on his pioneering research when it comes to Rett syndrome, because he's, my understanding, the only person in this country studying this particular epileptic syndrome. Is that correct?
From a animal model point of view, he's definitely the pioneer. Yes, yes. So he has animal models of Rett syndrome, and he has identified already in the classic Rett syndrome mechanisms of why he understands it in animals, and it makes sense that is the same cause in humans, why humans behave the way they behave. They have all the comorbidities and all the seizures. And much of what we know about Rett syndrome in humans, we learned that from the work that was done in these animal models that Dr. Eubanks created.
And what's the potential here, say 5 years down the road? Are you able to speculate?
I think we are talking about gene therapy again, and it's hard for us to say exactly which form. It might not be the CRISPR-Cas9, which is the one that most of us are familiar with, but it could be something called antisense oligonucleotide. It could be a viral vector that brings a piece of the gene that is needed. So there are many different forms of gene therapy. And of course, they will be first of all tested in these animals that Dr. Eubanks has.
Correct.
Before we can go to humans.
And another pioneering researcher at the Krembil Research Institute, Dr. Peter Carlin, talked to us about his organoids project involving so-called mini-brains. What's that about?
Yeah, so that's a fascinating thing. And I remember hearing the first time about this probably 20 years ago, and it was something far away in the future, and now we are living this. So what happens is you can take a cell from a patient that has epilepsy, and from this skin cell, you can make it regress and become a stem cell. If you remember, the stem cell is the cell that will generate all other cells. So then once you have a stem cell from your patient, you can make it develop again into neuron cells and all the other cells that form the brain, not just the neurons, because our brain has the neurons, but has other cells. And you can form actually a mini brain with layers of cortex, with cavity of the brain that is filled with liquid. And so it's like a fantastic model to understand why patients have epilepsy and how to treat. And in addition to being a model for your patient with that specific gene mutation, that little organoid or that mini brain also has all the other background genetics that your patient has. So we know medication A may work well for this patient, but not so well for that patient, because the background genes may affect that. So in these mini brains, you have all the background genes of your own patient. So you can really experiment as you wish. You can put cells of these mini brains and do EEGs on them. You can try many different medications and see if the seizure activity decreases with the several hundreds of different medications. So it's a spectacular model of understanding how seizures develop and what is the best way to treat them.
It's amazing. And this is just a slice of the epilepsy-driven research ongoing at the Krembil Research Institute. Okay, I want to mention, I want to bring in actually the guest that we mentioned at the outset of the show, Sangeeta Staley. Sangeeta is a passionate advocate for research and awareness of a rare developmental epilepsy disorder known as CDKL5 that you mentioned earlier, Dr. Andrade, CDKL5 deficiency disorder. Sangeeta is also the creator of the cdklcanada.ca website. CDKL is a gene and short for, help me out, Dr. Andrade, psych-dependent kinase-like 5. It's when this gene mutates that the disorder occurs. Welcome, Sangeeta.
Thank you, Christian, for inviting me to come and share my journey.
Well, we appreciate you having the courage to come forward and speak to us about your daughter, Tia, who I understand when she was born back in 2004, around month 4, like just 4 months old, she had her first seizure. And by 5 months, you mentioned that she was having more than you could count in a day. As a first-time mom, what's going through your mind when you see this happening to your baby?
First of all, it was devastating. It was devastating because, I was a first-time mother, and when you have your baby, even before they're born, you sort of already planned everything for them, where they're going to go to school, what you want them to do with their life. And you have all these hopes and dreams for them. So that was really devastating for me, because at that point, I'm filled with uncertainty for her future. What is, her future going to be like? I also was shaded with a lot of personal, doubt. I wondered about, why is she having all these seizures? Is it my fault? Did I do something when I was pregnant with her? And I felt really isolated. But I think that isolation was for the main part was me, because I didn't want anybody to know what was happening, because she was having that many seizures. I was having, I was internally blaming myself that maybe it was my fault. And I thought, okay, we'll find a drug and we'll manage her seizures, and then nobody will need to know.
But at the time, really, I mean, the CDKL5 deficiency disorder had only just been confirmed as a disease back when Tia was born, so it was not widely known. When you look back now to Tia's early years, she was exhibiting all the classic signs in terms of relentless seizures, days without sleep, nonverbal, gastrointestinal issues, developmental issues. You did not get this diagnosis, though, until she was 7. So talk to us about those years of not knowing, with all of these symptoms ongoing, but not knowing what was wrong with your daughter.
We did so many different testing for her, genetic testing, that is. Her neurologist tested for, Rett syndrome and FOXG1 and all of, the things that he thought could explain why she was having this many seizures and why we couldn't control the seizures. When she was 5 years old, she was diagnosed with autism. And I knew that the diagnosis didn't fit. As a parent, even though you don't have all of the answers, you still know when something doesn't fit right? And so it just didn't fit right. And we were so hopeful that we would find the proper diagnosis, because we thought that with that, then we would know how to better treat her seizures. And then maybe we can have some success in these areas where she was struggling.
And what's on offer for Tia in terms of, I understand there's no cure. So in terms of treatment, what is out there?
Well, so Tia's epilepsy is, like you mentioned, CDKL5 deficiency disorder, and it's a rare genetic epilepsy. And so basically what's offered to her is the same as what's offered to anybody with epilepsy, anti-epileptic drugs, the ketogenic diet, which is actually, she's not a candidate for that because she has some underlying metabolic conditions, the VNS, And none of these are, very successful because, we can't seem to control her seizures. They're drug resistant. So basically that's where we're at.
So over the years, you have actually become quite an expert when it comes to CDKL5 disorder, deficiency disorder. And you created an organization to serve as a resource for other parents in this situation. What's your message to those families coping with this disorder?
So my message is, and the reason why I started the organization is when Tia was diagnosed, there was no assistance for us, no help, no support groups. And, I did meet families on groups on social media, and that was really helpful for me. But in terms of treatments, I had to do a lot of research myself. And so starting the organization, I wanted to be able to have a place for families where they can go and they didn't have to spend hundreds of hours on the internet trying to find information. I just wanted it to be easier for them. And so my message would be to just have a really good, open relationship with your child's neurologist or whoever the treating physician is, because you both want the same thing. They want to treat their patient. You want to treat you want your child, treated with success. So I think open communication is really important. I think just to know it's not your fault that your child, is epileptic, and to seek support groups, because we do have CDKL5 Canada have established support groups, and they are on social media, which is wonderful right now, living through this pandemic when you can't actually go out and meet people face to face. So that's really good. So seek the support groups. You don't need to suffer in isolation. You need to participate in registries like Dr. Andrade mentioned briefly. I think she might talk about that some more, because we want to, have a natural history study of the diseases. We want to organize the population so we can, we can enable clinical trials, and just enjoy your child, because whether they have epilepsy or not, they're going to grow up. And when I look at my daughter, she's 17 years old, and I'm like, oh my goodness, I'm waiting for a cure, I'm waiting for a treatment. And while I'm looking at that, she's 17 years old, and it happens really fast.
What do you hope for Tia in terms of her future?
Well, obviously, I hope for a cure, but I'm a realist, and I know that that might not happen for Tia in her lifetime. So what I would really like for there to be, for her to have a really good quality of life. I think if we can make progress with controlling seizures for her, that would be wonderful. I think I would also like for her to have access to clinical trials. Like I mentioned, bringing clinical trials to Canada. So I think that's really important.
Let's bring in Dr. Andrade, who is now, I understand, Tia has transitioned to Dr. Andrade, your care.
Yes.
What is the latest that you can tell us? You mentioned Dr. Eubanks' investigational research ongoing in CDKL5 deficiency disorder. Where is he at, do you think, in terms of being able to move towards, say, clinical trials?
I think he would probably be between 2 and 5 years to go to clinical trials, and to go to human clinical trials. I mean, we're talking probably 2 to 5 years, because once you find a treatment that works very well in the animal models that have the disease, then you go to non-human primates, and you understand how that medication gets distributed throughout the brain, and then you can go to the actual patients. In the meantime, what we need to do is understand how patients with CDKL5 and all these other genetic disorders, how they evolve, what else happens to them. So, for instance, patients with Dravet syndrome, which is SCN1A, a different gene, they have very severe epilepsy, they have intellectual disability, they have autism. But when we started to look at them as adults, we saw that a large proportion of them start to develop Parkinson's symptoms at the age of 20, 21, 22. So this is the kind of thing that we are learning now, because these were considered pediatric diseases. But we see that the adults have many other problems, like the one I told you that developed schizophrenia. So now we have this that have Parkinson's and many other problems. So you want to make sure that the treatment that you're going to give is not only going to control the seizures, but it's also going to avoid the progression of a Parkinson's or schizophrenia or anything else that accompanies this specific gene. So you want to monitor all of those symptoms. So we need to understand the natural history of these diseases, and the registry is a big part of that.
And I understand in the US, there are centers of excellence, CDKL5 centers of excellence across the country, about a dozen of them. Do we have anything like that here in Canada?
We have some Rett syndrome clinics, which are similar to that, but still, once the patients turn 18, you don't have the same kind of treatment. So what we are doing in the adult side here is actually, we are looking at all of these genetic epilepsies together, because there are not too many of them, and these are all rare diseases. So we follow all of these patients. We have a multidisciplinary program. Our patients have at their disposal, we have a movement disorder clinic where they meet with a movement disorder specialist, a psychiatrist specialized in genetics, a genetic counselor, and nurse and social worker, and fellows and graduates. So, I mean, we have a complete group that is focused on all the many different needs of these patients. So patients with rare epilepsy can have a better treatment in the adult setting.
And talk to us, Dr. Andrade, what role could, say, philanthropic dollars play in helping to drive this kind of research ongoing at the Krembil?
Well, that is absolutely fundamental. I mean, we couldn't have done what we did without philanthropy. Just so you understand, when we write grants, we usually have the money to do the sequencing of the genes, but you still need the money to hire the research assistants that are going to contact the patients and obtain the consent and bank the DNA. We need money to keep a DNA bank, and we have a large DNA bank today, probably the largest in Canada, with epilepsy patients given the philanthropic gifts that we received. We need that to keep our databases going and to keep the salaries of all these people that work with us. Going forward with the registry, we have a grant that will allow us to collect patients, to put patients in this registry, but at a very slow pace. So without philanthropy, it's going to take years to build this registry. With philanthropy, we can do this in a year or less. So that's where it's extremely important.
And I want to bring in Dr. Bui too to advance this. What role does philanthropy play in advancing your work, Dr. Bui?
It's fundamental. When Sanjita, what a brave and incredible story. I think you're my personal hero among many of the women in my clinic. It reminded me of one thing, which is that you're not alone. And I said this just earlier today because I had a full day of clinic. I said to a woman, you're not alone, but we can't do this alone. And it's really this philanthropy that really nourishes the work that we do in the trenches with our patients. One example of how philanthropy has really catalyzed and changed the playing game for women's issues is that philanthropy and philanthropy alone allowed us to actually create Canada's first ever accredited training program for women's neurology. And it's the only one of its kind in Canada. And there's only two other programs in North America that has this. One is at Harvard, and the second is at Pittsburgh. And so philanthropy is what sustains us alongside of caring for patients and ensuring that we're doing the best that we can. So projects like the Lullaby Project, the registry for women's issues and how we're practicing and managing women's issues in pregnancy, and our breast milk study to see what is being transmitted, all of that couldn't be possible without philanthropy.
All right, look, we could keep going, but it's time for the audience to chime in here with the questions that have been coming in throughout our conversation, and I want to get to those. So first question, can you get epilepsy later in life, in your 20s, or are you born with it? Who wants to field that one? Dr. Andrade?
Yeah, sure. Yes, you can get epilepsy later in life. If you're born with it, if you have the genes for it, doesn't mean that you start having seizures when you're young. Our brain is always changing and genes are being turned on and turned off all the time. So if your seizures are supposed to start at an age where certain genes are supposed to turn on, and that is the gene that is abnormal, then you're going to start having seizures at your 20s. Of course, epilepsy can also be caused by trauma or infection, but if we're talking just about genetic epilepsies, they also, which are actually the cause of 75% of epilepsies are genetic. Even the ones that need surgery, most of them are genetic. So we are talking, it could start at 20 or 40 or any age.
I want to chirp up here as well because women have unique issues. Some women develop seizures in relationship to their menstrual cycle. And so looking back, quite a few of my patients first developed epilepsy at the onset of their menses. And so there are hormonal factors that play into the development of epilepsy at different stages in life.
Next question, how has the pandemic affected your work? Delays in treatment now? Who wants to take that one?
I can maybe tackle this one, and I'm sure Danielle has her own perspective. In fact, it hasn't affected my work. It's been actually very good, mainly because it's really transformed care into nearly completely virtual. And what that means for women with epilepsy who are pregnant and need to see me every month, it's a lot easier, especially juggling with who to look after the toddler, how do they get down on TTC, because many cannot drive because of their seizures. And so the familiarity of virtual clinics, the way the hospital has expanded to allow this to happen with a bigger bandwidth, really has made life easier for lots of women with epilepsy and pregnancy.
Dr. Andrade, I imagine COVID has impacted your clinic, et cetera, how you see patients?
Yes, we're also seeing most of our patients virtually. And I would say most patients are actually happier with this, so they don't have to worry about parking and all the things. It has freed up some time for us in terms of commute. We don't have to commute every day to work as well. So that has given us a bit more time to do research. But many patients that needed some more complex forms of EEG, like prolonged EEGs, those have been postponed because we are working, and the patients that need to be admitted for an evaluation in hospital, we also couldn't admit as many as we used to, so we are down to 60% approximately. So there is a delay in the investigation of some patients, and that certainly is a problem.
All right, next question. How accurate are epilepsy surgeries? I am 21 now and have deja vu episodes for 3 to 4 seconds. Am I a good candidate for epileptic surgery?
I can answer that. So,
by all means.
To know if you are a good candidate for epilepsy surgery, the information you provided is good, but we need to know much more. We need to actually know exactly where the seizures come from. We need to do imaging studies to see if there is any kind of abnormalities in the brain, like a small scar or something that is also generating the seizures. So once we have, and we need neuropsychological tests to see if a surgery could eventually affect things like memory or language. So we want to make sure that the surgery is extremely safe. So we need to do a lot more investigation. Now, I would say that for most patients that are good candidates, we're talking about 80, 90% chance of being seizure-free after surgery. And we are doing a study to understand how genetics plays a role on that as well. Because sometimes you have that patient that looks like a perfect candidate for surgery, and they don't have that result. And the other way around, some patient that doesn't seem to be such a great candidate and have an excellent result. So we are also looking at their genes to see how that influences the surgical outcome.
Listen, I didn't realize we went on quite a bit, and we have reached the end of our time. But for those questions left, don't worry. Someone from the foundation will be following up with you. I want to thank all our guests for a fascinating conversation today. First, Sangeeta Staley, thank you for sharing your story. We appreciate you being here today, Sangeeta.
Thank you again for having me.
Dr. Danielle Andrade, Medical Director of UHN's Epilepsy Program and Clinician Investigator at the Krembil Research Institute, and Dr. Esther Bui, Leader of the largest epilepsy pregnancy clinic in Canada at UHN's Toronto Western Hospital. Thanks to both of you for taking time out of your busy days to share your research with us.
Thank you
for having us.
As well.
And to all of you out in the audience, a big thank you from the Toronto General and Western Hospital Foundation for your continued support. Thanks for tuning in. Keep practicing physical distancing, wash your hands often, and mask up. Stay safe, everyone.